Well, good afternoon, folks. I am Dave Johnson, and I am not the person you're expecting to see right now. But we're trying to track down Nathan. Not sure what happened here. Appreciate those of you who've been patient, and I know that we do have some of you waiting here, and so we're glad that you are here. Please say hello in the chat, and we will go ahead and get started. For those of you who did stick around, glad that you're here. And I am thrilled today to be able to introduce Oliver Sild. Oliver is the founder and CEO of Patchstack, which provides an amazing service to the WordPress community as a whole, and especially to us here at SolidWP and for our customers, especially those folks that are using Solid Security. And Oliver, how are you today?
Good, good. It's quite late here in Estonia, but I already kind of getting used to it. So
Yeah, well, I'm really glad that you stuck around and messaged us to let us know there was an issue. I was I was going to join the webinar and listen, but I was running a few minutes behind myself, and so I'm not sure, what happened with Nathan. But of course, glad that you are still here, and
sure.
we've got folks saying hello, greetings from Germany. We've got various folks from different places saying hello. So actually, a couple of folks from Germany. Looks like Sweden. A number of
Oh,
folks. So
nice.
yeah, glad you're here. Oliver, I have no idea what Nathan was going to do in terms of introductory material. And so
I like
um,
it. So we can completely take over the entire session and do
a- a-
whatever we want.
the cat is away. The mice can play 100%. So I know that you're going to be talking about vulnerability mitigation, and you're going to explain a whole bunch of concepts about virtual patching. And so what I think I'd
Yep.
like to do at the moment is go ahead and turn it over to you. But before I do that, I want to mention just real quickly for those of you watching, if you have questions, then what I'm going to ask you to do is drop your questions in the Q&A box. And there is a Q&A box, which I think should be enabled. I'll double check. And so we invite you to drop your questions in. I'll be keeping an eye on those. And later, when we get towards the end of what Oliver has prepared to share with us today, we'll dive in and do some Q&A. And in the meantime, of course, enjoy yourself in the chat. And Oliver, I would love to just hand things over to you right now and let you dive in. And I'm here for anything that you might need along the way.
All right. Thanks. Just double checking to see my slides as well. Is that visible to everyone?
Yeah, I am
Um,
seeing them here, and so
yeah,
hopefully
I don't
others
see
are.
them, so so I'm just asking.
Yeah, very good.
But yeah, happy to have everyone here. My name is Oliver. I'm the co-founder and CEO of Patchstack. So for the past 10 years, I've been working on WordPress security and security in general. And those who know what Patchstack is doing already, we are, I would say 4 years ago, we were one of the first companies to launch a kind of open bug bounty program for WordPress ecosystem. So we run quite a large community of ethical hackers who find security vulnerabilities in plugins and themes and WordPress core as well. And we help those vulnerabilities to get fixed faster inside of plugins. So we also work together with the plugin developers. So some of the plugins that you're most likely using, like Elementor or different page builders like so, are all our partners. So we partnered up with them and helping them to kind of run the security processes correctly. And then we also work with a lot of hosting companies. So we have quite a stronghold across the entire WordPress ecosystem in terms of the different stakeholders that we work together with. But today, why I'm here, I would like to talk a little bit about vulnerability mitigation and specifically virtual patching as the means to do it. That's something I think we've popularized quite a lot over the past, I would say, 5 years, because as Patchstack, one of the main, I would say, quite literally the main thing that we are focusing on is vulnerability intelligence and then virtual patching. So something that we are quite proud of doing at this point, and we have data to back it, is that we are capable of providing the fastest vulnerability mitigation on the market with the virtual patching. So actually, before we dive into what virtual patching is, let's talk about why it even matters and why it's so important to make sure that it happens quickly. So let's jump back into February 10th, 2024. Some of you may remember there was a vulnerability patched by the team from the Bricks Builder. It was a remote code execution vulnerability. It essentially allowed you to completely take over the website, and it was quite bad. So let's see what happened essentially. So the vulnerability was actually originally found by Calvin Alkan, who then reported it to Patchstack. And he and us together, we work with the Bricks team to make sure that the vulnerability is getting fixed before any kind of information is getting made public, and essentially for the hackers to be able to access it and do something bad with it. Right? And something that we had the opportunity to do, because the vulnerability was essentially reported through Patchstack VDP platform and through our processes. What we were able to see is that we deployed the virtual patch rules to those customers that were running these plugins the same moment when the vulnerability was actually made public on our vulnerability database. Which showed us quite a few things. So one of the things that was quite specifically visible was the fact that the vulnerability was exploited in a matter of few hours. So the moment when a vulnerability was made publicly, as a public information through the changelog file, for example, that was provided by the Bricks team, but also through the vulnerability databases, different vulnerability monitoring systems and notification systems. From that moment when it became public, it took around 2 to 5 hours. I think it was 2 hours specifically for the vulnerability to become mass exploited, where thousands of sites were becoming compromised and so forth. And I would say, like, one of the key things to kind of take into account here was what we saw across the entire ecosystem is that most of the security measures completely failed. We were talking with hosting companies that were running Cloudflare in front of them. They were using ModSec. They were using different kind of like server level firewall solutions, network level firewall solutions. They were using, all kinds of hardening setups and things like that. But yet the websites were still completely taken over. And the same story, in fact, is with 50 plus other mass exploited vulnerabilities in 2024 alone. So this year has been quite significant in terms of new security vulnerabilities being found. And this screenshot is actually from the Patchstack vulnerability database, where, and I think the similar view you have inside of Solid Security as well, where you are having this information regarding the vulnerabilities that are also being mass exploited in real time. So for all security vulnerabilities that have high and medium priority, which we assigned as an internal ruling system, we apply virtual patches. And then if virtual patches are getting hit across the entire network of sites connected to Patchstack or to our partners software, which is providing virtual patches as well, we will have the insights in terms of what vulnerabilities are getting exploited where and in what volume. So you can actually see this information on our database and on other places. So I would definitely recommend checking out those indicators. Yeah, so let's talk about what happened to the sites that actually had the vPatching enabled, that were already receiving the virtual patching rules to mitigate the vulnerabilities. And the information, what happened was quite straightforward. The sites were actually safe. And we have talked to a lot of customers that have been deploying, Patchstack and our partner software across like a huge number of websites. And what they all saw is the fact that the attacks also started rolling in very, very quickly. And in many cases, I think there was 2 or 3 different attackers who created their own exploits, which were different ones, but the way how virtual patches behaved, all of them were mitigated, so the attacks didn't go through. So let's talk a little bit about, how is it even possible to provide that, that fast mitigation, or like why is it even so important to, be that fast? I think we covered it a little bit in terms of the speed to weaponization is what we call it internally, in terms of like how fast a vulnerability is becoming mass exploited. But like, let's talk about how it's even possible to, provide that kind of a speed. So when we look in terms of how we do vulnerability intelligence inside of Patchstack and how we are dealing with the virtual patches in general, is that we basically have 4 steps, right? So the first step is that a new security vulnerability is added into our system, and this can happen through mostly three different sources. So one of them is Patchstack's own bug bounty program. So we have quite a large community of ethical hackers who can essentially find vulnerabilities in plugins. And I think in 2023 alone, 73% of all known security vulnerabilities inside of the WordPress ecosystem were actually submitted through the Patchstack's bug bounty program. So quite a majority of the security vulnerabilities are actually coming in this way. Then what we have is called Patchstack's VDP platform. This is something that we quite recently launched at the WordCamp US, but we've been kind of like running it in stealth mode for the past year, I would say already, with some of the first partners. So we have right now around 450 different plugin developers on roll. So what it means is that Patchstack essentially controls the vulnerability disclosure process for some of the most popular WordPress plugins. So if you find, for example, a security vulnerability in Elementor, or doesn't matter who finds a security vulnerability there, if they want to report it to Elementor in a responsible way, they actually are submitting it through the Patchstack system. And then we help to validate this for Elementor, and then we are also capable of kind of like controlling when the vulnerability is getting disclosed in the first place. But that also allows us to provide the virtual patches and the protection available for our customers the same moment when this is getting published in our threat intelligence feed. And the third source is our internal threat intelligence team, which is basically half of our company. I mean, we're 30 people at this point, and we have like very heavy resources on security research and on threat intelligence. So we basically have like daily, like real-time monitoring of all different data sources, CVE systems. We track different databases additionally to ours. Essentially, any public information or even like a bird whistling somewhere about the security vulnerability, we are essentially kind of tracking those. I wish I could show you, but we have actually bots set up which are scanning the entire WordPress repository in terms of all changelog changes. So we also see when a plugin is updating to another version and where's their security fixes done, and when there's any kind of like specific patterns inside of the change logs where they are updating the plugins or releasing new versions. We are running, diffs and things like that. So quite a complex system, but we are basically monitoring the entire SVN and things like that. So that's also one of the parts where a lot of this information is getting fed into the system. And once this information is in the system, then we get into the step 2, which is we validate the specific vulnerability. So we verify every single vulnerability that is coming in. We don't really like to rely on anyone's other's kind of like assessment. So we always make sure that we kind of like, we know exactly what the vulnerability is, where it is. We try to exploit this internally on our own. We look into like the POC, stuff like that. So we want to make sure that the vulnerability that is reported to us, or that someone somewhere said that there is a security vulnerability in a specific plugin, we want to always make sure that this is like a valid information. We know exactly how it works, and that we can also test and we can confirm that it works as well. But this also helps us to actually enrich the data a lot. So we are, assigning our own scoring system, which is called Patchstack Priority Scoring, which is essentially like a, for us, replacement for the standard CVSS score system, which is kind of telling you like vulnerability is high severity or critical or medium and low. And, this is something that is being used to basically, which is like a standard kind of scoring system, but the issue with it is doesn't apply very well to WordPress. And for us, what we want to make sure is that there is as low alert kind of like a fatigue as possible in the ecosystem, because the volume of security vulnerabilities is so high. We want to make sure that our customers know exactly like what vulnerabilities to keep their focus on, and what are the vulnerabilities that they may be able to take maybe a day or two to kind of like patch it out, because it's in many cases like completely useless for ethical hack, or like for hackers to essentially exploit and things like that. So once everything, the data is enriched, once the vulnerability is completely reviewed and validated, we essentially talk to the plugin developer and we make sure that the fix is released before a vulnerability is being disclosed. So we help, again, if they are in the MVP program, we help them to also validate the patches that they send back to us. So if we send them a report about the vulnerability and then they say that they fixed it, we always ask them to send the patch back to us before they publish it to the customer base. So we can make sure that those vulnerabilities are actually, mitigated or patched. And so they don't a release an incomplete patch to the wild, and essentially they need to do it all over again, right? And then the third step is that we are setting up the vulnerability data into our vulnerability database. So that's when our partners and our users are receiving the vulnerability protection in most of the cases 48 hours before it actually made public. So what we have a system in our vulnerability database is that all the new vulnerabilities that we add, they have basically a 48-hour cooldown. So we want to make sure that the information is first available for the users before they are made publicly available for any hacker to basically try to get, to exploit that kind of information. So our vulnerability database and our partners have the access to these vulnerabilities 48 hours prior. And that's also the same moment when the vulnerability is getting virtual patches deployed to the customer sites. And later on, after the 48 hours, the information is getting publicly listed on the public database that everyone can see. And that's where anyone can get the information about this vulnerability. And those protection rules, which are called virtual patches, right now, as of date, we actually have 9,000 of them already, which kind of gives you a little bit of sense what the scale is, what we are talking about. I mean, it's at least 10 times bigger library of vulnerability specific protection rules compared, I think, to any competitor in the market. So I would say we're the only company actually taking this kind of approach where we have systems in place that we are capable of covering that high volume. So every vulnerability that you see in our database, there's markers on it. You can actually see that they have their own individual security rules deployed. And there is a very strong reason why we do that, but I will cover that in one of the next slides. But then, then the step 4 is that the vPatches, once made available, based on demand. So when a site is essentially having a vulnerable version present, the virtual patch is automatically being deployed on the site. And then if an attacker is trying to exploit a specific vulnerability, the virtual patch is essentially just denying them, and they won't be able to access the vulnerable function in the way that would be allowing them to exploit anything. So the moment that happened, that log or this hit against the vPatch is getting sent back into our threat intel feed, where the vulnerability, even in the public database or in any of our partners or customers applications, it will basically show as it's actively exploited. So there is a real-time insight in terms of okay, I have this vulnerability, but is there any kind of attacks around the world against this vulnerability already? So you will have a real-time kind of a flagging on those vulnerability information as well. It's important because sometimes, especially when you have more kind of enterprise level deployment systems where you kind of have your own release cycle, and then you're you need to let's say test the patches that are being released for the specific vulnerability, or release the new patch to, or a new version of a plugin, for example, into production, but you need to do it to JIT or different kind of workflows. Then you need to understand that whenever you have a vulnerability there, but now once it's actively exploited, you literally have no time to waste. You need to immediately react on that and get this patched if you don't have virtual patches enabled for some reason. So something that we do, which I covered also a little bit in the beginning, is that we work with every single stakeholder in the WordPress ecosystem. And this is something what I covered in the first one, which is the three sources: the bug bounty program, the VDP platform, and the internal threat intelligence. So as of today, there's over 450 plugins that essentially trust Patchstack as their security point of contact. So if any vulnerability is being found in Elementor, Cadence, WP Bakery, WP Rocket, at if and so forth. Like the list is quite long. You can actually check it out on our website. But if any vulnerability is found there by us, by any of our competitor or any ethical hacker or anyone, all the vulnerability reports go through Patchstack. So you can understand, like if you're a user, let's say, of Elementor or Cadence, or if you're a user of any of those plugins in our system, like the best security solution that you can literally use is Patchstack, because we have the capability of providing you the security rules even before they are, made public. But yeah, this can only happen through a very deep partnership with all those vendors. So we're super proud of being able to do that. And yeah, as mentioned, one of the oldest and most active bug bounty program in the WordPress ecosystem. In 20, I would say in 20. So this year in October, we actually helped patch over. I think we found vulnerabilities in 1,500 plugins. Was one of the biggest vulnerability hunts in the WordPress ecosystem. So there was, we helped actually. We created a campaign where we asked our ethical hackers community to find security vulnerabilities in abandoned software in the work, like the plugins that looked abandoned, because we've had issues in the past where security vulnerabilities are being found in plugins that have like, few thousand active installations. And if you report the vulnerability to them, it turns out there's actually no developer behind it anymore. And through this process, we actually managed to, I would say, remove about 1,000 plugins in the WordPress ecosystem, or from the .org repository, that were completely abandoned by the developers and they didn't receive any patches anymore. So these vulnerabilities, it's important for users to know that there's vulnerabilities in those plugins and there's no one to basically patch them or release those fixes. But all this is only possible thanks to the bug bounty program. I think we have around 2,000 ethical hackers in the community. And by the way, anyone can join this as well, because it's an open Discord community on our website. Again, if you go to the main menu and bug bounty, you can see the Discord and all the information about the community there. If you're interested in security, we have a lot of discussions going on there. And in 2023 and 2024, most vulnerabilities were actually published by Patchstack, 73% in 2023. 2024, I think this is pretty much in a similar stage. And yeah, because we also work with GoDaddy, Hostinger, with a lot of large hosting companies that are also relying on our data, but also we help them to protect their customers. We have pretty much unmatched visibility across the entire WordPress ecosystem, because we work with the volume, like, with Hostinger alone, over 4.5 million WordPress websites are getting scanned through every basically minute. So quite a large scale visibility in terms of like what vulnerabilities are the most prevalent, but also what kind of vulnerabilities are being most exploited, where the threats are coming and who is exploiting them, and all this kind of information, which is super important for us to be able to kind of like provide that speed to mitigation that we are hunting for. So let's talk about why, in my opinion, every single WordPress website should have vPatching enabled. So one of the things that is quite noticeable is that there's a significant year-over-year increase in new vulnerabilities. If I'm looking into quickly the data, so in 2021, there was 1,384 security vulnerabilities in total found in the entire WordPress ecosystem. In 2022, this jumped 300% to 4,500. 2023 is 6K already. And that now 2024, the latest number right now in 2024, we have already passed the 2023 numbers by 1K. So we're already 7,000 vulnerabilities found and basically published in 2024 alone. So 7,000 vulnerabilities now. So quite a high number of growth of vulnerabilities. And honestly speaking, we only see this information going up. One of the reasons why is that with AI, like we run an AI program internally. We work together with Google. We are actually working in a Google AI and cybersecurity program. So we have access to their models. So we have 2 people working full time on our modeling. And we already run internal tooling that is basically like an AI model where you feed in a WordPress zip file and it basically responds to you with all the security vulnerabilities inside of the code base. We will soon write about it. You're actually the first one to know about this project. And we are planning to make this available as a tool also for plugin developers, so they can already during the development process avoid a lot of the security vulnerabilities. But again, AI is finding a lot of security vulnerabilities already, at least in our inside of what we are doing. Virtual patches is by far the fastest way to mitigate new vulnerabilities. I mean, you cannot protect yourself against what you don't know about. So being able to know about vulnerabilities and basically providing the protection to them is literally the fastest way. Patching for, let's say, updating to a patched version in 30% of the cases, vulnerabilities in plugins don't actually have a fix officially released by the developer. So you would be waiting for the developer to release the patch, and then you can update. And updating in general, in many cases, is not something that is available, especially on enterprise. I mean, auto-updating specifically. So the fastest way to mitigate new vulnerabilities is by far virtual patching. It's also the most specifically, it's the highest precision that you can get in terms of protection, and it also has the lowest number of false positives. So every single virtual patch is custom made on spec for every single vulnerability, which means that you can make it super strict without the worry of it basically causing, breaking everything down or like causing false positives when you deploy it in the wrong place and things like that. So it kind of has like very low impact on the site performance as well, and it's in general quite. I will show you after this one as well, after this slide, like how the vPatch looks exactly. So you will get a little bit of a better understanding of like what it actually, like how precise it can be and why is that. Something about virtual patches is also that it makes no changes to the files or the plugins. So there's no code changes at all on your website. So it essentially runs on top of your application. And it kind of like has like this kind of like a protective layer on top of the functionality that you are running. So if there's a vulnerability, a vPatch is basically covering that security hole inside of the code without actually changing the underlying code. And that's important because in this case, you don't need to there's no like interference with your version control. There's no kind of like interference with updating plugins, things like that. If you update the plugin, virtual patch is not getting removed, or it is getting removed only in the case where the plugin when the vulnerability is actually fixed in this new version. And also in terms of the lowest impact in performance is that you don't need to, like, we don't deploy 9,000 virtual patches on every single website. We know exactly what kind of vulnerabilities are present on the site, so we deploy only the ones that are specifically needed at that given point of time for that specific website. And then, it is by far the most effective solution against the attacks because it's so precisely kind of crafted for every single vulnerability. So if you think about like how it kind of like works on a timeline or in a system in a practical way, there's like visitor going to the website, and then there's essentially the website communicating with Patchstack or our threat intelligence database and the vPatching database. So for example, if the Patchstack engine is polling from the website, hey, what are the versions of the software being installed here, and then it receives the information about the specific versions of plugins and themes and things like that installed on the website, and then it cross-checks it against our vulnerability intelligence. And if there's any match against the vulnerability being present in a specific version, a virtual patch is automatically being deployed inside of the website. So now if a visitor is coming to the site and they try to basically use any kind of functionality on the site or just kind of browse around or enter information in the form, the functionality that is, for example, vulnerable is getting essentially like a whitelisted for this specific use case. So if someone is trying to use that functionality in a malicious way, the request is getting blocked and it's getting logged back into the system. So we know that this vulnerability is actively exploited, but they were not able to actually complete the exploit. So when I'm talking about this whitelist based of thing, so this is a good example. So there's a let's say SQL injection vulnerability, which is a very common security vulnerability where you essentially inject data into database, or you pull database information outside based on some queries, and some of the things that we can do with the vPatch is that, for example, there is a SQL injection vulnerability in show details parameter, and you can essentially inject the SQL injection payload into the ID parameter. So for us to be able to essentially virtual patch the SQL injection inside of this parameter, we don't need to rely on like pattern-based like firewall rules that are causing false positives and things like that, where you're kind of like trying to like patternize like whether this is like an exploitation attempt or not. What we can do is we essentially, the virtual patch is just setting a parameter, which is post action. The value is post show details. And then the post ID parameter has to match a type called C-type digit. So essentially what we are doing is that we are capable of, our virtual patches are capable of basically having like if and else argumentation. So it's almost like every virtual patch can be kind of like a program where, for example, if show details in ID is not the number, which it has to be, like the logic of that specific parameter was that you are asking for ID, which is always have to be a number in this case. If it's not the number, you block it. So we don't even need to think about like clever ways for someone to try exploit it or like try to do some sort of obfuscations or things like that. Literally, if it's not the number, it's not going to work. So that's where you get like this very, very precise, very strict security rule, which is very, very hard to bypass without any kind of false positives, because we can deploy this per vulnerability only on the sites that they need it, and it's entirely focused or like specific to those parameters as well. So as mentioned in the past, like virtual patches are super important, and this is not being done by the way how virtual patches should be done in terms of having very strong threat intelligence below it. This is not being done by a lot of vendors that actually do say that they do vPatching. We've seen all kinds of companies say that they do it, and in reality, they don't even have the data to do it. So the data is kind of like giving away whether there is a capability for it, because being able to provide virtual patching all comes from the bottom of the data, because you need to know exactly what you're patching. So the data is super important here. So based on our experience, some recommendation that I would give to you is don't rely entirely on your hosting. I've seen hosting companies pop up now and then, essentially saying that they do provide like power, all kinds of promises in terms of security, and eventually you will end up realizing that they're just using Cloudflare Enterprise, maybe like Immunify or something like that on the bottom, where they are just running the ModSec security rules or generic firewall rules. And then, as we had this specific case in early February, if there's a vulnerability being mass exploited in a very latest security vulnerability, which is super logic based, I would say, and very kind of like very, very specific, then these kind of solutions don't necessarily keep you protected. So I would say the approach that you should take is it's your application, so it's your responsibility. I would not believe that much in terms of like a lot of the promises that a lot of those DNS-based firewalls and things like that are doing, if they don't actually have the data to know what they should be doing. So I would recommend you to take the responsibility on your own application and essentially make sure you control the security on your own. And obviously, one of the ways to do that is either through Patchstack or through Solid Security Pro, which we are partnering with. So I hope you are aware that Solid Security Pro actually has Patchstack fully integrated. So you don't even need to have your own Patchstack account or anything like that. All you need to do is essentially enable Patchstack vulnerability mitigation, like virtual patching inside Solid Security Pro. And all of what I was talking about will automatically apply to your websites. And yeah, you would get the fastest protection on the market. What I was talking about, to receive the 48-hour early protection through the vulnerabilities that are reported through the Patchstack VDP platform, but also through our own threat intelligence, but also through our bug bounty program. All this information is getting first-handed through our partners, such as Solid Security Pro as well. So you will get all that value. And obviously the full vulnerability reports about every single vulnerability that is going through our system is available through Solid Security Pro. So yeah, my next slide is questions, but I would rather leave that slide here.
All right. Oliver, this is fantastic. I appreciate the deep dive here, as I know our listeners and attendees do. And I did find out, by the way, that there was a mix-up about the U.S. time zone here. So I don't know how easy it is to mix that up from Estonia, but this event was set up for one time in one system and another time in the other. And so Nathan popped in my chat and he was like, "Hey, what happened?" So
okay.
yeah, he joined a half hour early. He thought to jump in and make sure that everything was going to run according to plan. So appreciate everybody who's been paying attention. I want to just drill down, if I may, and we do have a couple of questions that have come in. And so real quickly, I want to just mention, if you're watching and you have questions, go ahead and drop them in the Q&A. We do have some that have come in, which we'll get to in just a second. But Oliver, I feel like there is a piece of this that is still relatively technical to somebody who may be just a typical WordPress site owner who maybe doesn't spend time with development and doesn't maybe has a cursory understanding of vulnerabilities. And so I was wondering if you could do me a favor, or do us a favor potentially. Can you talk about sort of the difference between what Patchstack is doing with virtual patches, that which, as you mentioned, are super very tightly constrained? In other words, they're very focused. Can you discuss the difference between that and maybe something like a web application firewall or a WAF or another solution that I think you mentioned, like, hey, we don't deploy 9,000 rules against your website, but can you talk about what the difference is between a vPatch and maybe just a traditional WAF?
So in terms of traditional WAFs, I think we need to talk about the DNS-based firewalls, and then there's different kind of firewalls in the system available, but like, for example, let's talk about Cloudflare, which is a WAF that everyone probably knows about. The thing with Cloudflare is exactly the same. So they don't know what they're protecting. Like, they have no idea what is behind Cloudflare. So they don't know what your website is made of. And for that specific reason, Cloudflare also needs to deploy every single rule that they have essentially in front of your website. In Cloudflare's case, it's not a problem because their resources are being used to basically, rotate through all of that data basically and make sure like every request is coming in and it's being run through all of every single rule of like that. But when we talk about other WAFs that are essentially sitting inside of your server, now it's a problem, because if your website itself needs to rotate through, I don't know, thousands of security rules at every single request, that's probably not something that you want to have if you want to have a very performant website. And the only way to do that, or like not to do that, I would say, to not have a WAF run through, I don't know, thousands of rules, is that the WAF has to have like a full visibility into the application. It needs to understand what it's made of, what versions are running there, who is the visitor, like what is this visitor authenticated as an administrator, so we don't need to activate a specific rule because of that. All this kind of information, and this can only happen when you deploy this kind of a solution through vPatching and inside of the WordPress application. And then there's also this difference between like web application firewalls that just do like a generic, we block OWASP top 10 kind of thing firewalls, where in reality you are having just like a bunch of regex rules, which are just like, don't use semicolon and like some, special characters in the URL. Like if you use it, it looks like a very hacker thing, so we block it. But then in some cases, if you're looking into like post requests internally and there's like metadata and things that you need to deal with, it starts to produce a lot of false positives. And this is the reason why most of the generic firewalls like ModSec and things like that are based on kind of like this generic pattern-based rules are super optimized to a point where they would not cause false positives. But this optimization means that it's actually pulling down the effectiveness of the firewall. So it's starting to, it's basically like finding this balance between like, we need to block like 99% of the stuff, but when we block 99% of the stuff, we also block like 50% of the stuff that should not be blocked. So they start pulling it down, like, okay, we block like 80% of the stuff, so now we block like a little bit less the things that we shouldn't. And then it's being basically pulled down to a point where the kind of like a performance of the WAF is like quite questionable, where like half of the stuff goes through and half the stuff doesn't, but then it's like, it's like a half security, right? So if you, and that's, I think, the main difference between the WAFs and the virtual patching approach is that with virtual patching, we know if there is a vulnerability, we're going to virtual patch this vulnerability and we are target that specific vulnerability. And if your site doesn't have it, we don't need to run that rule there. We don't need to pull down your site performance and things like that. So it's a lot more work to do virtual patching. It's a lot less work to do generic firewalls. So that's one of the big differences, I think.
Excellent, excellent. Yeah, I appreciate that that dive into how that works. And you're talking about less work and more work. One of the questions that's come in is actually specifically about how much work is getting done. And so, what should someone expect if Patchstack has to understand the nature of every single query coming in to a site, and then intelligently figure out whether any virtual patches apply in that particular case or not? How much of a load is it? Can you talk to the performance piece? I understand from what you've said, it's significantly less than if you were running a sort of generic firewall.
Yeah.
But how much of a load is it?
I think when we started building the engine, what we call the Patchstack vPatch engine, which is actually based on, we built it in PHP, so it was not even built for WordPress. In there, like, we can run the vPatching on any kind of PHP application, and then we built the WordPress wrapper around it, and soon you will see that becoming available also for other content management systems. But when we built it, performance was one of our key kind of like key things, because as you noticed, as I mentioned previously, we work with a lot of large web hosting companies. There is a reason why you don't see, products like WordFence, for example, being deployed across, in a volume to a lot of those hosting, infrastructures. It's because of the performance impact it has, because, they just deploy every single rule that they have to every website without even knowing what kind of vulnerabilities there are. So for us, it was super important to make sure that the way how we are basically deploying those rules is per demand based on vulnerabilities, but also that we cycle through the vulnerabilities in as close way to the native PHP as possible. I think there was someone in the WordPress community, I think David McCann, who was actually running the plugins, different security plugins, and comparing the memory use of, I think it was like Patchstack was like 14 times less performance. I mean, I need to double check that, but it was like very, very, basically the lowest amount of resources required to run it. And it was intentionally made it so, because we need to deploy this on a very large scale. So yeah, the more your server does least work, who does the most work is our team. That's where all the work is getting done. As I said, like half of our team is security engineers. So we have like 24/7 basically coverage in terms of finding new vulnerabilities and making sure that every single one of them gets vPatches. We test every single vPatch with POCs and things like that, and then making sure that they are getting released to our customers before anyone else can do that. So
yeah, I appreciate it. It's a piece that as you know, Oliver, I joined the SolidWP team well after this integration had been dreamed up and developed and implemented. And so when I came along, one of the things that I was super impressed about was the choice of using Patchstack for this purpose was made out of the same philosophy that the Solid Security team has used in the past when they were trying to identify. Actually, they removed quite a few features from Solid Security Pro over the years because they were essentially saying, like, this has no actual security benefit, and we're wasting resources by allowing users to turn it on or use it, whatever it might be. And so that's actually the reason why Patchstack was chosen to be the solution for protecting the Solid Security Pro users from vulnerabilities was exactly that. It's intelligent, it's smart, and it doesn't drain the server resources in the same way that other approaches might do.
Yeah.
We've got another question from Vern. Vern was the one who asked the question that you just answered, but Vern also asked, how chatty is Patchstack? You mention or hint that my site will provide feedback to you on any actual attacks or blockages. Should I be concerned about all that traffic leaving my server?
Yeah, there's no traffic leaving your server. So Patchstack is sitting inside of your application. The only information that is being passed with, like between Patchstack and between your website, is your website telling us what kind of software it runs. So plugin versions, things like that, sends that information to Patchstack, and we respond with the corresponding virtual patches that your website needs. Because again, we don't want to load everything on your website, so we make sure that this information is getting there on demand. And the other thing is then when vPatches are getting hit, the information is then being, like, the logs of the virtual patch hits are being sent back to Patchstack. So you would actually also be able to see what kind of attacks have been blocked and things like that. So this information is purely for yourself, but also, yes, we also use that information in terms of like triggering or like tagging the vulnerabilities that which virtual patches are getting hit as actively exploited. There is actually a module available inside Patchstack as well, which is called the community IP feed, essentially, which is basically collecting those hits against vPatches together in the bundle, and you can deploy them additionally in front of your website. We are working in like a hybrid model where you could actually deploy that into a Cloudflare. So you will get those IPs added from Patchstack, but then you deploy to Cloudflare, because that's where you should do this kind of like a generic traffic filtering and not necessarily inside of the application. So, but this is something that we're still working on and could be a value as well.
Yeah, excellent. I appreciate you diving into that too. It's also fascinating to me the sort of question about who finds the vulnerabilities and how they get how they make their way into the various security solutions is an interesting one. And I know you talked about 3 different ways that Patchstack has an advantage on having that information available, perhaps ahead of others. One is just the bug bounty program that you run, where security researchers actually report the stuff to you early. And then the VDP program, which plugins and themes and others can use to be the first line of receiving reports themselves about stuff, and then your own threat intelligence team. Now, this is something Solid Security, for example, has never invested in having a team of security researchers. Other plugin solutions do. Other security companies that
Very
build.
few do, actually.
Yeah,
I think there's I think maybe only 3, to be honest.
Right. But and that research is valuable to the WordPress community. Whoever does the work, it's valuable. Whether it's independent researchers that claim bug bounties, or whether it's teams like yours or teams like others. That's just a huge impact. Can you talk a little bit about what led you to build a threat intelligence team and do research yourself as Patchstack on the WordPress ecosystem?
I mean, it's who we are. That's the thing, right? So I was doing malware research like 10 years ago already, or something like that. That's how I actually started the company in the first place. Our co-founder, Dave, he was a bug bounty hunter. He's the CTO. So he was actually studying, he did his master's in cybersecurity in the US when we actually met in Reddit. So that's a funny story about Patchstack, is that our founding story comes from me and Dave meeting in a PHP security subreddit.
That's
completely
priceless.
Online.
That's great.
And then working few years together, not even seeing each other, and now like running this company together and seeing us, very, very often. But yeah, that's how the company kind of gets started. And like, because both of us have been technical founders, both of us have been basically doing security, it was logical that we basically started like with a very heavy focus on this kind of R&D and threat intelligence side of the things. So now we have people from we have 2 or 3 people who previously worked in Sucuri, that was acquired by GoDaddy some time ago. Analysts like security analysts from there who are very they have 10+ years of experience with WordPress security in general. very like we've managed to get on board very like kind of high quality people. But I think this is the reason why I think is also focused or like connected to the fact how we focus security. Like we have a very specific focus. Like one of the questions that we've asked, I think 5 years in a row, is like, when you're starting to do malware scanning. And it's like, never. Like the reason why we are so good at protecting your websites and providing this like the fastest protection for security vulnerabilities is because we only do that. It's that we only literally focus on that, and all our resources go to preventive security, just making sure that those hackers don't get in your site and just infect it with malware, because most of the cases, you know, the way how they get in is through vulnerabilities or getting in through your like credentials and stuff. But credentials is an easy fix. So
do you would you be okay? I've got something I could show real quick that might help some folks visualize.
sure,
You know,
absolutely.
would it be okay if I share? I might just take over sharing real quick.
I will stop sharing my own. Yeah.
Yeah, super. I'm signed in right now to a demo account of Solid Central, which a lot of our Solid Security users may have never even really had a reason to sign into Solid Central in the past. But this is something that is available if you're purchasing Solid Security Pro during our current Black Friday, Cyber Monday sale. You'll have the ability to attach your sites to Solid Central. And what I think is great about this, you can see I have a few sites connected here. This is a demo account, but these are actually live websites. And one of them is a site that I started a few years ago for a project that's not active anymore, but it accepted donations. And if I switch over here to the vulnerability screen, you'll see that I have a 10.0 vulnerability sitting here. And I'm telling a little bit on myself in two ways. One is I haven't updated the site, so that's a problem. But also I work very closely with the team from GiveWP, and so I want to just say they did a fantastic job patching this vulnerability, releasing a patch for it a few months ago. But you'll notice I have a 10.0 vulnerability on this site, and I'm not worried about it. And the reason that I'm not worried about it is because it's mitigated via a virtual patch. And this is the kind of thing where if it happened in the middle of the night, that a vulnerability was disclosed, became public, and started to be exploited, and I don't have time, or I feel I was asleep and didn't update a plugin to a patched version, which, by the way, is often how people learn. Those who are trying to exploit vulnerabilities find out about them often because they also do the sort of diffing and analysis that you were talking about. Yeah, so they look at two versions of a plugin, they find out there's a security release, reverse engineer the differences, and say, hey, here's what we can exploit, and they go after it. And then these days, those exploitations are happening, instead of being days or weeks like they used to be,
it's hours.
Yeah, it's very rapid. And so
it's if you don't have auto updates enabled, and it happens to be deployed, like if the let's say vulnerability is getting or like a fixed version is getting released in the middle of the night, all the SVN monitors are going basically start screaming that there is a security fix done in the new version, and they immediately look at the diffs, they figure out what the vulnerability fix was, and they start exploiting the vulnerability. So that's why it's happening super fast. So either you and the other thing is, like, as I said, even the auto updates don't, like, we have so many cases, and actually the data, like we do the annual state of WordPress security report for 2 days, 2 years in a row. What we've seen is that in 30% of the cases, the vulnerabilities, like 30% of the vulnerabilities did not actually receive the fix by the author before it was already disclosed. So
yeah, it's relying on automatic updates. I mean, automatic updates are better than nothing. But
yes, but like
they're prone to problems of various kinds, and that's one of the things that you can see with a solution like Central here. But I'll just jump over. Like, if I were to look at this in the Solid Security plugin, you can see that this was patched automatically, and it was patched, back prior to, actually, many months prior to the public disclosure of this particular vulnerability, because there was a vPatch that was already available and was protecting my site and others. And so I just wanted to have a quick way to demonstrate that and allow anybody watching to see how that works. We do also have a question it's not really a technical one, but it's just related to subscriptions. And Gene asks, for those with a Solid Suite Toolkit subscription that do not include the full Patchstack license with virtual patching, is there a SolidWP sale on for separate Patchstack licenses? And so this is the case when the rebrand happened over to SolidWP and iThemes Security Pro became Solid Security Pro. At that moment, anybody who bought Solid Security Pro licenses, whether they were part of the suite or just on their own, started receiving the Patchstack virtual patching licenses at the same time and could go activate those right away. But for anybody that was a previous subscriber, and a lot of those folks have kept their subscriptions alive, there is a way for you, if you contact the SolidWP account services team, just reach out to the team. They can make sure that you get what you need in order to license your sites. And yes, those are also on sale during Black Friday, Cyber Monday. So I think that answers the question you're asking, Gene. Let me know if there's any follow up to that. I think yeah, go ahead.
I think security might actually be the best thing to spend money on Black Friday. I think it might have the best ROI.
Honestly, it's true, right? if you
Yeah.
if you think about the cost of repairing a hacked site, there are lots of things that you can do to make that recovery quick. But at the same time, if you take your store offline or any critical website offline as a result of something that's entirely preventable, that cost is something you don't want to have to pay later. So,
100%.
yeah, we also thank you for that comment though. We also have something from Vern. How often will Patchstack on my server contact you to see if there are new items that may apply to my site? And I think there's a sort of maybe there's a nuance here with depending on whether something like Solid Security is running or whether Patchstack is running independently as it does or through another
Yep.
solution. So can you talk to a little bit about how that contact back and forth works?
So your site is sending the versions that are present on your site whenever there's a change happening to Patchstack. So if you're updating a plugin, a new version is sent to Patchstack. So it's kind of like keeping in sync. So we kind of like keep like a report of your website on our side. It's like, this website, this WordPress application, they currently run this version, things like that. And then completely like separately from your site, internally on our system, we basically match like, okay, this site is running those versions. What do we have in the vulnerability database? What kind of virtual patches and what is happening in terms of the vulnerabilities? So this kind of like, this is happening real time. Like on our side, it's happening real time where we cross-check it against the information we have about your website. And as soon as there is a hit of a new vulnerability added to our data set, which is affecting a specific version of a plugin that is installed on your site, then we actually push the vPatch on your site the same moment. So basically, the moment when we make the vPatch live, or like when we put it live together with the new vulnerability, your site is immediately mitigated. So that was important for us to basically have that kind of speed, because we can't rely on, who's more technical, we can't rely on like the internal cron jobs of WordPress, because they only get triggered with the traffic and usually like twice daily and things like that. But yeah, for specifically virtual patches, we only keep in sync the software setup that you have, and then whenever a vPatch is becoming available for a specific version, we just push it.
Very
and it's
good.
getting automatically enabled.
Yeah, it's very good. So, and the follow up to that is, so my site has a channel to you all the time so that push works. And of course, obviously that, the site has to be able to communicate that stuff to you in real time when, let's say, a plugin changes. Yeah.
There's an API connection between the site and between Patchstack.
And it's very lightweight. It's encrypted. Like there's no, it's a very secure and minimally impactful. Yeah.
There's like the information that is being passed is very minimal, right? As I said,
exactly.
Like it's a very small JSON information about what is the versions, and then sending back the information about the vPatches. But I showed you the vPatch on the slides. It's like the engine is already sitting inside of your site as the Patchstack vPatch engine. The only information that is being moved back and forth is the intelligence that the engine needs for a specific how to like run the engine in a correct way with the correct arguments and things like that. So these are like this small JSON is very powerful inside of our engine. So that's the only information that is moving back and forth, and the logs. But like logs depends on the site, of course. And logs, yeah.
Yeah, that's okay. And so yeah, quick follow up, which I appreciate. Vern's also asking then if that API connection gets disrupted, does the engine keep working?
Yes.
Yeah.
Yes. So the engine keeps working. If there's any downtime of the API, the vPatches that are already present on your site, they keep working. The engine keeps working. There's like no, and that is also was an important factor, right? And that's the benefit of running the engine inside of your application, because if we don't want to route your traffic through our system, because then if our system is down, your system is down.
Exactly.
So in our case, there's no risk of that whatsoever. The engine runs on your application. The vPatches that it receives are sitting there based on, as long as there is a version that is corresponding to that vPatch. I don't think we've had any downtime in the past, but you will, if there would be a downtime, for example, then nothing happens and you will receive the new vPatches as soon as it's back up. But yeah, that's a
Very good.
hypothetical thing.
Yeah, yeah, very good. All right, appreciate those questions. Also, I'm going to ask you, if you would, Oliver, in just a moment, to just share any final thoughts that you have with us. Before we do that, I just want to mention one other thing real quickly. Since Nathan was not able to host today because of the mix-up, I just want to mention a couple of things, and that is, one, this is a live stream that's free today with Oliver. Great information. This is the kind of thing that you get all the time if you're a member of Solid Academy, and Solid Academy has a premium offer. And so there are a lot of live streams and courses and other things, including office hours, that are not available for free. Those are part of the paid Solid Academy subscription. So I want to mention to you that you get Solid Academy as part of some of the purchases that you make. And during the time here that we have the Black Friday, Cyber Monday sale, for example, Solid Academy is a bonus item with some of the offers. So be sure to check those out if you're keeping an eye on the sale. The sale has started today, by the way, for Black Friday, Cyber Monday for SolidWP. Office hours happen every Thursday. This week, they're not happening on Thursday because it's Thanksgiving here in the U.S., and so office hours will be tomorrow at the usual time, so 1 o'clock to 2 o'clock Central Time. But there are also some other great events coming up. And I want to mention that if you are interested in this and other great events, including an amazing backlog of years of fantastic information, most of which is still relevant today. Some things change frequently, but if you're in the WordPress space and you build websites, you're a freelancer, you're running an agency, and you want to make more money, be more effective at what you're doing, you'll find many countless hours of incredibly valuable training available in Solid Academy. And so I just wanted to take a quick moment and mention those things. And of course, Oliver, so grateful for you joining us today. This has been such a great walkthrough of all of what Patchstack does. I know so many times we get questions about, hey, how does this work? And why is it so much more effective than maybe some of the other solutions that are out there? So Oliver, I can't thank you enough for taking the time today. I know it's very late for you in Estonia, so we need to let you go and go to bed probably. But is
Thanks.
there anything you want to leave us with today? Any final thoughts?
Yeah, I think people should take a little bit more responsibility over their own applications. That's what I wanted to say as well in the beginning. I mean, everyone wants to get on the security bandwagon, but you need to really make a difference in terms of who are putting hard work into security, because that's where you get the best results from as well. So take care of your websites. I think it's worth it. You invested a lot into it, so make sure that they're staying up. And
Yeah.
super happy to have been invited here. So
Well, we're grateful that you're here. And I will say, even if you are watching today and you're not someone that's ever purchased anything from Patchstack, you've never purchased something from SolidWP, you don't have solid security, we all, regardless of whether we've ever paid any money to Patchstack directly or indirectly, we all owe a huge debt of gratitude, because Oliver, you and your team are making WordPress and all of our websites safer. And so thank you for the work that you're doing. I know that you're, you have investors, and there's a financial reward and all that stuff that comes from the services that you sell. But at the same time, you could be doing a lot of different things, and we're all much better off as a result of you doing what you're doing. And so thank you to you and your team.
thank you.
All right. And thank you to you for watching today and joining us. And if you're catching the replay, we hope that it's been useful for you as well. And we hope to see you on future Solid Academy events. Oliver, thanks again. And we'll talk to you very soon.
All right. See you. Bye.
All right. Thanks, everybody. Bye-bye.